So, we're going to talk about our second method of division of polynomials. Now, we've talked about long division of polynomials. We are now going to talk about the second method. And I will be honest, I think many of you will prefer this method of polynomial division. The reason I teach long division first is because typically it's people's less preferable. And once I show this method, it's a little bit easier. I will say this method kind of reminds me of the box method of factoring. The box method of factoring is kind of a trick. It's not really a mathematical process. It's just a weird little trick that works every time, right? Now that's what this is too. This is a trick for dividing polynomials. This is called synthetic division. Synthetic division. Now synthetic, what does it mean? Fake. Kind of is what this is. It's fake division. We are dividing, but we're not doing it in a traditional sense. We are doing it in a weird kind of trick way. So I'm going to have this kind of setup for it. Kind of like when we did the box method, you had to draw a box with 4 parts. There's going to be a setup to synthetic division. You are going to take and put a little box in the corner here, like so, and we're going to put a number inside this box. We're going to put a number inside this box. The number that goes inside that box is going to be the opposite of this number. Now when I say the opposite, I mean this is currently a negative 2. Its opposite would be positive 2. So you're going to flip the sign of this number and put it in this box. So this is a negative 2 right now. It's going to become a positive 2 in this box. Now, right outside of the box, we have a couple more numbers we want to write. Those numbers are the coefficients to each term in our numerator. The coefficients to each term in our numerator. So, what's the coefficient on x to the 4th? 1. You don't see it there, but it is there. 1. What is the coefficient on 8x to the 3rd? 8. So, as we go through here, we're going to then put 9. We're going to put negative 38. Got to have the signs with it. You must keep the sign. And then we put negative 40. We're going to leave ourselves a little bit of a space. And then we're going to draw a line. And we're going to draw a plus sign. Because unlike long division, we're actually going to be adding in portions of this as opposed to subtracting. So what we are going to do, did I really?
No.
I did not know I taught you this in geometry. Everybody should know this then.
No.
Really?
I like that.
I don't remember this from memory, but we definitely
Okay, well this is going to be super easy if you remember it. If not, it's still going to be pretty easy. So what's going to happen is if we want to divide out our x minus 2 from our polynomial, we're going to follow this weird kind of pattern. First off, our first term, in this case a 1, but whatever it may be, is always going to drop below this line. It's going to drop below that line and it's going to be what it is right below the line. As soon as that number drops below the line, what it will do is it will multiply with the number in the box and it pops back up. So 1 will multiply by 2, creating 2, and then we're going to write a 2 back up here. We then add 8 plus 2, 10. And as soon as a number drops below the line, it's going to multiply by what's in this box. 10 times 2, we get a 20 up here, right? Now, let me reposition that better under the 9. But we get a 20 up here. 9 plus 20? 29. 29 drop below the box. It's going to multiply by what is in here. 29 times 2 is? 58. Negative 38 plus 58 makes? 20. 20 times 2? 40. Negative 40 plus 40? 0. Now what happens is this 0 at the end tells you, I like to say that it tells you did the problem correctly. What it really tells you is the problem doesn't have a remainder. Everything it came out clean on the problem. Everything worked out. It means we don't have a remainder. We are going to have problems where we don't get a 0 there because we end up with remainders, but those are going to be more few and far between. But for right now, you should expect to get a 0 at the end of this problem. Now, what does this tell us? That's really our question, is what do all of these numbers tell us? Well, it's close to our answer. Yeah, we have to add in the variables. Because what this did is this took out that 2. This took out that -2 from the problem. It ripped it out. We still have to take out the x, and the x is going to get taken out on our part. So we started with x to the 4th. So what do you think our answer is going to start with? If we start with x to the 4th and we're taking out an x, it's going to start with x to the 3rd, exactly. So I'm going to put x to the 3rd here, then x squared, x, and no x, a constant. So we end up with 1x to the 3rd plus 10x squared plus 29x plus 20. That's our answer. That's our process of synthetic division. We divided out x minus 2, and we got this polynomial. If we want to do this with another example, just so we have a second one of these problems to look at, we can. What I'm going to do is I'm actually going to use this same problem we had here. X to the 3rd plus 10x squared plus 29x plus 20. I want to divide it by something else. Let's say x plus 5. Now whenever I'm setting up this problem, whenever I'm doing my synthetic division, all I have to do is I have to start by writing my number in its box. That number is going to be what in this example?
-5.
-5, because we take this, we flip its sign, and then we write that in the box. So positive 5 flip is a -5. Now what do we write next to the -5? 1 and
Plus 10.
10
Plus 29.
29
Plus 20.
20, right? Those are all of our coefficients from the numerator. We're going to write a plus sign and leave ourselves a little bit of a space, and we can start doing our synthetic division. Our first step is always to do what here? Drop down our first term. Drop down to 1. 1 goes below, and as soon as a number hits below the line, what's it going to do? Multiply by the number in the box. So 1 multiplies by -5, making -5 go up here. These add 10 plus -5, or 10 minus 5, 5. Multiply by the box. What am I going to write here? -25, 4, and then multiply again, -20, and we get 0. That again means we don't have a remainder. This problem came out kind of perfectly. It divided out really well. So our answer will be, well, we have to get the x's in there first. We took out that 5, but what is the highest exponent that one of our variables is going to have?
X squared.
X squared, because we started with x to the 3rd, we have to take out another x. So we're going to have x squared, we're going to have x, and our constant. So x squared plus 5x plus 4. That is what we get from our synthetic division. All right. That is synthetic division. If you all have any questions, hit me up on the email or comments. Let me know.